Welcome to this morning's panel discussion. AI at the inspection level, is it a myth or is it a reality? Now, inspection systems, of course, are at the heart of Industry 4.0. It provides all the positional accuracy that we can then upload to the software systems that keep us informed about what's happening on the line, traceability, and in some cases tracing defects, etc. Joining me here today to discuss this, I have a very eminent panel. To my extreme right, we have Brian D'Amico, President of Murtec in the USA.
Thank you for having me.
Thank you. To his left, we have Vadim Shishov from A-Leader Europe.
Thank you.
Okay. To his left, we have Dr. Subodh Kulkarni from CyberOptics.
Good to be here.
And then to his left, we have Dr. Brian Kang from Young.
Thank you for having me here.
Great. So thanks for joining us, gentlemen. I'm going to jump in very quickly with my first question, and I'll start at the end. So, Brian, automatic programming, is it, an absolute must these days in an AI system?
Yeah, I'm going to say yes. Most of the manufacturers out there now have got some form of automatic programming, some or other form of automatic programming, and the reason for that is there's many benefits to auto programming. One is you can program very quickly, right? So it requires less time to program. So for those customers who've got low to medium volume, that's extremely important. You don't want to spend 8 hours writing a program. But two, you get better quality out of it as well. The whole purpose of automatic programming really is to make it so that you don't have to rely upon such a knowledgeable process person to program the AI. What you really want to get, of course, programming is everything, right? That whole mantra, garbage in, garbage out. You could have the best machine in the world, right? You could have the best hardware, the best software in the world, but the program itself is really what's going to give you the results, whether you can test everything and catch everything, or you're going to have an escape or false calls. So we really want to remove what's called the artfulness in programming. And that's what auto programming can do. It can actually take and allow someone who may not be so proficient with the machine, maybe a new-time person or someone who's just starting out with process knowledge, but it can take and allow them to program the machine very well. And this way here you can get quality results from the machine. So I do believe auto programming is pretty much a must out there now.
Right. Okay. Well, I think it certainly helps, if you've got it set up correctly, it certainly helps reduce the potential for any errors or manual mistakes, that type of thing, for sure. Would you agree with that, Vadim?
Yes, I think that we're talking about more like shortened programming time simplification, because it's coming from the customer needs. Because when the user or customer starting to make a program, they are always under pressure. Mm-hmm. They are, because the boards are ready, all stations are ready, everybody waiting for him. So in this case, if under pressure, he will not use all capability of the machine. If he's doing program like fast way. Mm-hmm. In this case, auto programming, first of all, ensuring that the program will be, as my colleague said, the high quality. Secondly, they use all capability of the machines, not a fast shortcuts. And secondly, it's independence of the customer experience. That means the newcomer and the person who, like superstar in the factory, they will do the same quality program. Mm-hmm. And the customer will be, it gives certain flexibility also to the customer, to the manager, to give the programmer to different people in the factory, not only waiting for someone who's doing the best.
Right, right.
So I think auto programming is not like an option, it's no choice. It has to be in each AI.
And and that's true. There's a much higher mix environment in most factories these days. And people need to get products up and running. The changeover time is critical. So it needs to be something that's fast and accurate. And that's another driver, I think. Let me ask you, Subodh, what sort of different systems capture the data? What sort of different ways can we capture the data for an automatic programming system?
Fundamentally, I agree with the comments already made here. Auto programming is here to stay, and it's already part of most of our systems. Many of us are doing similar versions of auto programming. For many generic SMT applications, that's clearly important because, as we have discussed already, variability is taken out, time is reduced, everything becomes more efficient. The only caveat I would add is there are some very demanding non-SMT type applications where you have to be careful that auto programming can be taken into the wrong side. And I'm talking about some of the defense related applications where not all the parts can be programmed ahead of time. And that's where you have to make sure that there are some flexibilities left in your systems to be able to capture and program each part individually if needed because of the uniqueness of those programs. And more what we are finding is customers want measurements, not just inspection. And when it gets into measurements, you have to be careful. Auto programming can create some limitations because the fiducials and the datums can be very different. So there is a variant of demanding applications that may demand that you move away from auto programming. But by and large, for majority of SMT applications, auto programming is good and works well for all the reasons discussed earlier.
Right. I mean, Dr. Kang, I mean, we all agree that automatic programming is important, but people are looking for accurate measurement of the device around. Then you might put that into a library of some sort. But you know, how important is it to get accurate, and what's can you bring AI into this?
Yeah, so I think that's a clear point of the what makes difference between the working auto programming versus the non-working auto programming. Particularly, we are dealing with a lot of different components, and if we are just to stay as like a 2D world, it's really hard to make a precise alignment or to get a correct programming because of the limitation of the information. So if you have a true measurement of the different like a 3D information or some other informations which enable a true auto programming by providing all enhanced information together. So like you mentioned that the acquisition of the correct data or the precise measurement is the key of the auto programming.
Right. Okay. Great. Is it better to measure every device independently, as you go along? Because, I mean, one of the issues we have in the industry, Brian, is that you might buy a device or load a device to a machine from a certain vendor, then you run out of that part and you move on to the next part, and it's the same value, but it's a slightly different geometric size because it's come from a different vendor. Is that something that you need to be aware of when you're programming inspection?
Yeah, absolutely. So every device is made with tolerances, right? There's tolerances in everything, in the machines themselves, of course, in the devices, the solder, the boards, all that stuff. So realistically, the programming has to be done in a manner where you can, for a particular package, say like an 0603 or an SOIC 16, we would build in those tolerances so that we can accommodate multiple different manufacturers. Having said that, of course, it's very important to measure each device. Now, are you asking about just during the programming portion of it or during the inspection portion of it?
Well, I think when you're programming, you're putting the information in there. It's coming back, so you've got to make sure you've got the right information in for each device. So if it comes from a different supplier, that's not in your library, then you need to measure it again from scratch, because otherwise it's come back to your rubbish in, rubbish out theory, and when it gets further down the line, it's going to start dropping off the nozzle of the pick and place machine or something like that.
Absolutely. All right, so if the device is in the library, right, we know what the device looks like, we know how many leads it has, we know all the tolerances, etc., then what we would do is, of course, program via that package type. Right, we have several different package types out there, and that would once again accommodate the tolerances. If it's a unique device that we've never seen before, quite frankly, at that point, we'd have to program from scratch. Right, we'd have to take and we'd have to learn the length, width, height of the device, put in any coplanarity type of measurement or tolerances that we require, leads as well, and then that once again gets stored to the library. So the way that would really work is anything that we know or anything that we already have a recipe for, if you want to say recipe, that we have all the tolerances built in, of course you'd want to do that right up front. That is very fast. But there's always going to be unique devices. There's always new devices manufactured out there, and there will be forever. So ultimately, we have to have the ability to deal with those unique devices and build in the tolerances associated, because the devices are made up of, bodies and leads, etc. We know what those tolerances should be. So that's where maybe a little bit more of the artfulness comes in creating a package that can accommodate varying different manufacturers' tolerances.
Right.
Like, it is a bit of a challenge. I do understand that. And of course, some of the military stuff we see, unique devices all the time are coming, new devices. So I think it's going to be an ongoing concern forever, but we could definitely deal with it, and I'm sure everybody's machine can deal with that.
Right. So would you agree with that, Vadim, that you've got to use you've got to measure every new device that comes into the library, basically. And now your system, you said you were using some AI in it. So explain
Yes.
to me a little bit about what you're talking about there.
I think that's the point. So we're talking about devices. So okay, we can use the library. You know, we can take a big library of different packages, like preset, like tens of thousands packages. The problem is when you're coming to machine learning, the actual inspection, it's not only devices. Imagine you have a same component. On some boards, it's on the big pads. On some boards, in the small pads, different alloy, solder alloy, different SMT process. You know, different profile on the reflow oven, for example. The all looks different. You will not get it for any information about device in the library. So, but you need it for machine learning
So
to separate
how
it.
do you compensate for these variations in the process? You know, we've talked about measuring the devices to be inspected, but you know, if you change the paste, or you know, it has a different characteristic on the meniscus or something like that, how do you know? Do you have to? How do you factor that in?
I would like to add the customer request. For sometimes, you know, if you're talking about acceptable defects, what we call process defects, you bring the same component to the different people and the same customer. One say acceptable, one say it's a real defect. The machine should take into account also that when we come into the programming. So it's much more deeper level than actually the device form, shape, sizes traditionally used for long years.
Right. Okay. So, what do you think? What other process parameters should we
So,
be looking at?
Yeah, the philosophies do differ at this point as to how you treat parts and different variations that are coming along. At least in our case, what we have chosen to deploy for the last few years is what we call principal component analysis. So it takes you away. So we are looking at the shape, and we are doing a vectorical analysis, if you will, of the images. So we essentially the same as what Google Picasa does. So if you do a sunset picture on Google and all the other sunsets come in, they are doing a vectorical analysis. The basic science is called principal component analysis.
Right.
That's essentially what we have been using, and it works very well in subtle variations and the kind of questions you brought up. It has its limitations too, just as every technology has its pros and cons. Principal component analysis can be computationally intensive, but the one area that every advancements are happening is computer horsepower is cheaper and cheaper horsepower is available every year. So long term, I do believe principal component analysis or some variant of AI or deep learning is the way to handle the variations once your program is done.
Right. So you want to capture these variations, but you don't want, you know, you're under some time constraints as well. So you've got pressures there on both sides.
Correct.
How do you approach it, Dr. Kang? Trying to capture these other process variations.
So I think what you want to try to achieve is how to make the less variations can be get into our programming process, right? Depends on the different component. There might be some tolerance ranges that we have to deal with it. From our approach is if we start with a standard basis, like for instance IPC 610 is a description of the component that we can rely on, everyone can agree. If we can have a way of the measure our data mapped to that standard, then tolerance can be easily tuned. So that's how we come up with our auto programming is by utilizing 2D 3D informations to map to that IPC 610 standard. And then starting there, we basically push our programming process with respect to the standard.
Okay. Well, I mean, IPC 610 is actually quite a wide variation. I mean, plus or minus 50% for the lead to be on the pad is huge these days. You know, given the geometries of most boards assemblies.
Yeah, exactly. That's the starting point. After that is basically we utilize what customer wanna see it. So the other side of the program is not just about how to map the component correctly. You have to basically also understand what customer wants to achieve there and has to be a part of the programming process. For instance, different business segment may have a different tolerance range that they are looking for, and the programming process has to adapt that as well.
Right. So Brian, I mean, do you think that with miniaturization coming into the industry so much, is inspection really going beyond the point of human ability to really visually inspect boards. You really need AOI. You just can't.
Well, you're talking to people who sell AOI,
Well,
so
I
yeah.
understand that, but I'm trying
But
to
I
get an
understand
objective
the
answer here.
I understand the question, but
Right.
it's actually a resounding yes. I mean, all right, so we're all getting a little older. Some of you are younger than me, but if you ever notice your reading material tends to get further away from you, right? Your arms are getting shorter, you got to put your glasses on, right? Same thing is happening, only in reverse. You could be 20-year-old, have a great eyesight, but as that text gets smaller and smaller, you have to have something that allows you to see it. Same thing when it comes to inspection. As devices are getting very small, there is absolutely no way you can have a human being inspect for those kind of devices. You have 0105s, 03015s. You can barely see that stuff in the naked eye, and even under magnification, they still look very small.
Yeah.
So my take on that is exactly the
make an
industry has come to
interesting-
the point where you need AOI.
Yeah. You make an interesting point there, because I think human eyesight has actually changed over the years because of the use of
Mine
computers.
has.
Yeah, but yeah, and mine too. But I think we're all using computers all the time, and I think that's degraded our eyesight. Had we not been using the computers over these years, I think our eyesight has degraded faster.
I think you still need AOI even if you had perfect eyesight.
Okay. Well, okay, that brings me to my next point, which is, we all agree that the AOI is absolutely critical and necessary, but I've gone into quite a few factories where they're using it offline. Doesn't it need to be online or inline, should I say, to be able to really take advantage of the closed loop processes that we're trying to introduce for a smart factory environment?
I would like to answer that. Look, inline have a definite advantage that it gives the feedback for continuous process improvement. Because today the defect prevention, it's one of the major tasks for AOI system, not only classic defect detection. I mean, today repair process sometimes just impossible. I don't say it's expensive or causing further damage to the board. So inline, yes, but sometimes offline is also justified. If you're talking about prototype inspection, when you're talking about like 10, 20 boards batches, often common in the Western Europe. Even with inline machine, you will not be able to give any feedback for such a small amount of boards. Or if you talk about small SMT shops, for them it's one budget restrictions. For them, off the machine is a good solution because you can use one machine for number of lines or number of batches. Essentially, inline, that's the best. So you can get real-time feedback, you can improve the process. You can say, okay, you need to change this feeder, or you need to calibrate that pick-and-place head. SPI, when you need to fix the printer, which has more than like 40 factors which are affecting the printing quality, then in this case it's a must, and it must be inline.
Right.
However, the offline sometimes it's justified. And I think the best combination for the big factories is the offline and inline in the same factory, which can use the same programs. So you can make the prototyping on the offline machine, and when you go the high volume, you automatically just load the same program on the inline machine and keep running the production.
Well, okay. Subodh, I take Vadim's point that in an MPI shop or very, very small shop, there is a case for having offline AOI, but really the game here is to try and capture the defects before they occur and auto-correct them. So I think really if you're doing any kind of volume at all, surely inline is going to be critical.
Absolutely. I mean, if you are in high volume production, inline has huge advantages. I mean, you are giving active feedback. You can do something about it. You can truly improve your yield and productivity. So there is no doubt inline has a significant role. The only thing I would add is there are some lower volume processes where and new products particularly, where customers don't know what exactly they're looking for when they start using AOI. And
Right.
there is a legitimate role for offline AOI in those cases where they want to review the data, they want to change the programs even after the data is collected and do other things besides regular inspection. And that gets again into the metrology world. When you get into metrology, they don't like inline metrology as much as they like offline metrology.
Right.
Because you can do a lot more things once you have all the measurements and what other areas you can look at. that they don't know a priori that this is what they are going to look at.
I know,
So-
but then you're falling into the area where you're having a production meeting to say how much scrap you made last week.
and that is the downside. That's why metrologists typically don't
Right.
control the product in line.
Absolutely, absolutely. You know, another phenomenon I've noticed is that a lot of manufacturers are reluctant to put post-placement AOI. You know, they'll put an SPI system in without any worries, and they'll also put a post-reflow AOI system. But trying to get them to go post-placement, you know, is a bit of a hard push. But it's still very necessary, you know, to have that information before you start baking the components onto the board. But is that a function that should really start to come inside the pick and place machine, that post-placement AOI, or is that still something that should be a separate box afterwards?
I think that's what we should do because of the two reasons. The first thing is there is a way of that you can correct it before it goes through the reflow oven, that you can make the correction. The other thing is pick and place machine might be having some defect. It is much easier to catch those defects at the pre-AOI station instead of after post-AOI.
Right.
The way we have a more precise way of analyzing it, what's the root cause of that errors caused by pick and place machine. And then also you can basically enable a whole so-called factory process optimizations through the entire line.
Yeah. I mean, Brian, you sell these machines all the time. I mean, why don't manufacturers understand that once the board goes into the reflow oven and you bake that component on, you're into big money to have to rework it if it's wrong?
Yeah, absolutely. Certainly, everybody's aware of the fact that the further at the beginning of the line that you find the defect, the least it's going to cost to resolve the issue. Right? If you have a bad screen print, you can, of course, wipe off the board and start again. If you pick up that defect post-placement, you can either take tweezers and turn it around or, you know, put the right component there. And then once it's reflowed, you get into rework, which you could possibly hurt the board, scrap it. So, of course, people are aware of that. What it really comes down to often, and more often than not, is money, right? Because you are buying another machine, and it is another process. It's money. Quite frankly, for people who do high volume, you know, people who have the deep pockets, it makes sense, absolutely makes sense. For those manufacturers who aren't quite doing that volume, they would just simply rely upon a post-placement machine or a post-reflow machine. And I understand that, I do understand that. But realistically, the best of all worlds would be if you had an SPI system, you had a post-placement AOI and post-reflow AOI, which would allow you to take, as my colleague said, take all the information and find out exactly where the process is broken. Because the whole goal really is to eliminate the defects before the board comes off the reflow oven. That's very, very important. And then there, of course, you're testing with the final AOI post-reflow to make sure everything's going well. So I think more than not, it comes down to really budget.
Right, right.
I mean, really, real world, it's budget.
Yeah, that's true. Okay, I've saved the best question for last. I'm going to start with you, Vadim, on this. Can you really use AI, true artificial intelligence, in programming
I
boards?
think, you know, my opinion is, okay, what we do, we have no choice, we have to. That's the situation today because all this, you know, I'll tell you more. I think these all component libraries and per part number, per package, in the future will go away. It will not need because basically you can get form of the component specifically from the machine itself, from simple measurement. The biggest challenge is to detect the defect and have lower force on them. And that's you coming, as I said before, it's much deeper level. You're coming to solder joints. You go, you know, you take OCR, just OCR optical character recognition. It's
But aren't you running into a time issue there? I mean, if you're talking about measuring everything from scratch, an AI system that's smart enough to be able to measure everything from scratch, how long is that going to take?
No, it's not a measure from scratch. You use some experience. So you take into the machine ready. I take OCR, okay? You have different forms, different types of printing. You have a laser etching. You have a different inks. You have a different components, different materials, ceramic, plastic, metal. So you put, in our experience, you can put into radio on machine, you deliver like 99% of the information. I mean, you can detect 99 automatically without any involvement of the user, 99 maybe more % of the writing, and with a ready library. So the remaining 1% you can teach the machine. I mean, not to show samples, to teach, let machine learning, feed the learning algorithm into it. The question, when you do that, that's another question. The question how you do it and when you do it. So you can give it to customer, where you risk something wrong will be learned in, or you can gather information and carefully select the information in your facility in R&D, and then supply a different version with the new information. But the principle is the same.
Okay.
So
Okay.
as many installation you have, as wider data you get, you use your developed algorithm to learn the stuff. And then you come to solve the joins. The solve the joins really vary. That's everybody works with IPC level 2, level 3, but understanding is very subjective.
Right. Right.
So your machine has to be able to tackle with that and also filter the operator mistakes. Always possible that operator newcomer coming
Yeah.
and say on the real it's a false.
Right.
Machine has to know you're wrong.
Okay.
So
Subodh, do you agree with that? One day we'll be able to do away with libraries. That the machine learning will be so advanced and fast that we'll be able to use AI.
AI is a catch-all phrase, and it captures everything from basic analysis and algorithms to all the way to deep neural networks. So, as I said earlier, we are already deploying one form of AI as principal component analysis to do basic kind of analytical work right now. But it takes like a PhD level scientist a whole day to program your different hierarchical deep neural networks. I have my doubts as to how soon deep learning or deep neural networks are going to be part of AOI systems in a high volume production. Maybe in some unique cases relatively soon, but in some cases probably a long ways off. So I think AI has different flavor. Clearly AI is being deployed already, but I don't think it's the Star Wars like robots that are going to do everything automatically and teach humans anytime in the next few years anyway.
Well, we've got the best person to ask next to us here. Dr. Kang's working in this every day on AI and neural networks and that type of thing. How far away is it?
I think it's pretty close. The thing is, we have to be very conservative about that, not try to apply AI for everything. The best way of doing it is based on the best domain knowledge that we have built over many, many years. We have to identify that where will be the best place that we can apply AI selectively. If you have already a system that working perfectly without AI, we shouldn't touch it. So our approach is a little bit different. Instead of trying to deploy AI for everything as a black box, we basically dissect every steps, and then based on our domain knowledge that identify that a very specific areas that where we can get a best outcome by applying AI. That's how we should do it for now. After that, once we build these foundations, we can gradually toward to everything AI in world. I can presumably thinking about when it's gonna be happening, but I can feel it. It's coming soon.
Okay. That's a cryptic answer. Okay. Well, gentlemen, I think we're running out of time. Do you want to have one last word on this, Brian? Or
Actually, I do. First of all, I agree with everything that my colleagues have said, quite frankly. But AI, the way people think of AI, they think of course, Siri, and there's going to be robots walking around. Really what we're talking about is machine learning. That's really what it comes down to. So yes, there's certain processes, there's certain information that we can collect and take what's called big data. And the whole goal is to take that big data and to use that data, historical data, that we've captured from each one of the inspection systems in order to make the line as efficient as possible. So that's really what we're talking about, is using machine learning with big data to resolve those common issues that we would see in the manufacturing process. Do I believe that AI is going to take over? And I think it's a little bit longer off than you may agree with. I think it's going to take quite a few years. But the whole goal, once again, is to eliminate the fact that we require an extremely talented process engineer in order to program the line. We want the machine learning and the historical data, which is, of course, we require very good process engineers to create that historical data, to create valuable historical data. But artificial intelligence is really just the ability to make a decision based on data that we've collected and analyzed and learned That's really what we're doing, and it's by learning, analyzing, collecting all of that big data. So I think we're a bit more off, but I do believe that we're making leaps and bounds and great strides, especially in this industry, in working towards that goal. And we all have a common goal, and that common goal is actually a big benefit to our customers as well.
Zero defects.
Yeah, zero defects, that's a common goal. Thank you, Trevor.
All right, gentlemen, we've got to end it there, unfortunately. We could go on at length on this topic, and I know there's some conflicting views here, which I'd love to delve into, but for now, I'm going to say thank you for joining us today. Brian D'Amico from Murtec, Vadim Shishov from A-Leader Europe, Dr. Subodh Kulkarni from Cyber Optics, and Dr. Brian Kang from Koyoung. Thank you, gentlemen, and thank you for joining us today.